In this second part of the video, we'll take a look at a couple of applications, leaning ladders against walls, using the distance formula and such, and then we'll look at the other side of these equations. In the previous radical equation examples I did, we're always squaring or cubing both sides. What if it works in the other direction? What if we have to take a root of both sides in order to solve? So here's the first application problem. It says a 6-foot ladder is placed against the garage with a base 3 feet from the building. How high above the ground is the top of the ladder? So here's my building. Here's the ground. So I'm going to put my 6-foot ladder against the garage. All right, so when I lean it up against the garage, here's the ladder. Now, it tells us the ladder is 6 feet, so that's fixed. It says the base is 3 feet from the building, so there's 3 feet from the building. How high above the ground is the top of the ladder? So that's H. We assume the building and the ground make a right angle, and we've got ourselves a right triangle. If you remember the Pythagorean theorem, maybe from a high school geometry course somewhere, the two legs are A and B, the hypotenuse is C. The hypotenuse is always the longest side of a right triangle. It's also the side that's opposite the right angle. So the formula is A squared plus B squared equals C squared, or C squared equals A squared plus B squared. That's the Pythagorean theorem. Let's fill in the numbers. We have a 6 squared equals, I don't know what the height is, but I know the other side is 3. Square first. So 6 squared is 36. 36 equals height squared plus 9. Let's subtract the 9 from both sides. 27 is equal to h squared. Now, I should take the square root of both sides. Normally, if I were just taking a generic equation, I would take the square root of both sides and put a plus minus before that square root of 27. But I know the height of my building cannot be negative. So I'm just going to leave this as the square root of 27 feet because it tells me the measurements are given in feet equals a height. Now, two things. I can simplify the square root of 27, right? Square root of 27 breaks down square root of 9 square root of 3, which is 3 square root of 3. Right, so I can also answer with a simplified radical. I can also get a decimal approximation, like if I were actually trying to figure out how far up the side of the building it went. When I got to the final answer, I might put it in my calculator and see that the answer is a little bit more than 5. 5 squared is 25, so 27's got to be a little bit more than 5 squared. All right, the Pythagorean theorem actually helps us to find the distance between 2 points on a coordinate plane. Those 2 points don't have to be vertical or horizontal like the ones in the previous picture. Suppose they were just any 2 points on the coordinate plane. Here's x1, y1. Here's x2, y2. So point number 1 is down the bottom. Point number 2 is up on the top. And I would like to find the distance between those 2 points. So what I'll do is I'll extend the vertical and the horizontal. So I'll extend this piece down. I'll extend this piece across. And look, I made myself a right triangle. If this is y2, that's the highest y value. This is y1, that's the lowest y value. So it makes sense then that this side of my triangle is the top value minus the bottom value. Let's look at this length over here. If x2 is the larger value for x, right, the ones to the right are going to be the larger values. The ones to the left are going to be the smaller values. So this distance down here is the right value minus the left value. And so if I set this up as the Pythagorean theorem, I'd get d squared equals the bottom, which is x2 minus x1 squared, plus the other side, which is y2 minus y1 squared. So c squared equals a squared plus b squared. Normally when we write the distance formula, we solve for the d by taking the square root of both sides. And we only include the positive because we're not going to have a negative distance. We're only interested in how far it is from one point to the other, regardless of what direction or whatever we might be going. All right, so look at that formula there. You want to see a nicer typed up version? That's what's on my next slide. So it's the difference of the x's squared plus the difference of the y squared, add them together, then take the square root. So here it is, distance formula between 2 points. Difference of the x, and you could do the difference of the y squared and then the difference of the x's squared. Because there's a plus sign in the middle there, it actually doesn't matter which way you go. All right, let's use this to find the distance between 2 points. So let's say I gave you the points -1, 2 and 6, 4. Remember that these are x's and those are y's. So the distance formula says take the difference of the x's and square it. So you can choose whichever way you want. If you want to do 6 minus a -1, you can do that. You can do -1 minus 6. Doesn't matter, you're going to be squaring it in the end anyway. And then for the other one, we'll do 4 minus 2. That's the difference of my y's. All right, remember, 6 minus a -1 gives me 7. 4 minus 2 gives me 2. So I get the square root of 49 plus 4, square root of 53. All right, what is that? It's a little bit less than 8. Actually, a lot less than 8. It's a little bit more than 7. It's more realistic. And if you can't simplify the radical, then just leave it like that. All right, you'll notice that the example on the next slide is exactly the one we did. I just wanted to do it on the same page as the distance formula. So we went between -1, 2 and 6, 4. All right, like I said, the previous examples we did solving equations, we always had to square both sides. Sometimes you'll need to take a root of both sides. And it's helpful to remember that rule that says the nth root of x to the n is the absolute value of x. Now, we had done one with the square root, right? We had said the square root of x squared is equal to the absolute value of x. This one expands it. It says as long as that n is even, then the nth root of x to the n is the same as the absolute value of x. So take a look at that first one up here. It says 3 times x plus 4 to the 4th equals 48. Right? A couple different ways we can approach this. Whichever way you do it, you're going to divide by 3 first. And you'll get x plus 4 to the 4th equals 16. In order to get rid of that 4th power, I'm going to need the 4th root. So I'm going to have to do the opposite, right? So to get rid of a 4th power, you take a 4th root. So I'm going to take a 4th root on this side and a 4th root on that side. Now, that rule that's up on the top with the nth root of x to the n, that's going to come in real handy. Because look what I have on the left side. I have the 4th root of x to the 4th. The 4th root of x to the 4th is the same thing as the absolute value. On the right side, the 4th root of 16 is equal to 2. 2 times 2 times 2 times 2 gives me 16. And now I have a nice simple equation to solve. Either x plus 4 equals 2, or x plus 4 is equal to -2, because what's inside that absolute value bracket could be either 2 or -2. Either one will work out. Subtract a 4 from both sides. I get x equals -2. Subtract a 4 from both sides here, and I get -6. Try it back into the question that 3 times x plus 4 to the 4th equals 48. Right. If I put a -2 in here, 4 minus 2 is 2. 2 to the 4th is 16. Multiply it by 3, we get 48. Okay, what if I put in a -6? If I put a -6 in for x, I'd get 3 times -2 to the 4th. Well, -2 to the 4th gives me a positive 16, times 3 again is 48. So both solutions work. X equals -6, x equals -2. All right, let's take a look at these two. Up on top, I want to get rid of that 1/2 first. I like to get rid of the coefficients of my terms. So let's multiply both sides by 2. And I get x minus 1 to the 5th equals 32. Now, I need to take the 5th root because I have a 5th power. How do I get rid of a 5th power? A 5th root. So I take a 5th root on this side, and I take a 5th root on this side. We don't have a rule for odd roots. like the one we had for evens, that the nth root of x to the n is the absolute value. Here it's not, because I can have negatives under a fifth root. That's not an issue. The only issue is if it were under an even root. So the fifth root of x minus 1 to the fifth is just x minus 1. The fifth root of 32 is 2. 2 to the fifth gives me back 32. Add a 1 to both sides. X is equal to 3. That's the only answer. No 3 or negative 3, just 3. So put a 3 in here. 3 minus 1 is 2. 2 to the fifth is 32. Half of 32 is 16. It works. All right, let's try one more. Let's try number 2. If we want to undo a second degree, we need a second root. So it's got to go opposites. So take the square root of both sides, square root of this side, square root of this side. The square root of something squared is the same as the absolute value. So I get the absolute value of 4 minus 2x equals square root of 100 is 10. And so what's inside that absolute value bracket can be positive or it can be negative. So 4 minus 2x could be positive 10, or 4 minus 2x could be negative 10, because then when I take the absolute value, it'll be back to positive 10. All right, so subtract a 4 from both sides. Negative 2x equals 6. X is negative 3. All right, so I get negative 2x equals negative 14. X is equal to 7. All right, try it out and see if it works. If I put in a 3, put in a negative 3, I get 4 minus 2 times negative 3. Negative 2 times negative 3 is 6. 4 plus 6 is 10. And sure enough, 10 squared is 100. All right, let's try 7. 4 minus 2 times 7 gives me 4 minus 14, which is negative 10. Take negative 10 and square it. I get 100, which still matches up with the right-hand side. And so both of those solutions work. X equals negative 3 works. X equals 7 works. All right, last problem. Sometimes as we're solving these things, we actually want to solve for a variable because that'll help us to figure out how to make an equation work that has multiple variables in it. So here's the formula: volume of a sphere. I just came up with 4/3 pi r cubed. This is the volume of a sphere. This is set up so that I input the radius and I get out the volume. But what if I wanted to do it a different way? What if I wanted to input the volume and find out what radius was the radius for a sphere that matched up with that volume? So I'd want to solve it for r. What's keeping that r from being by itself? Well, for one thing, we've got that 4/3 in front, so maybe multiply both sides by the reciprocal to get rid of that 4/3. So I get 3/4 v equals pi times the radius cubed. All right, let's divide both sides by pi. This gives me 3 over 4 pi times v, so the v goes on the top, the pi goes on the bottom, equals r cubed. Now, the question said solve for r. So if I have this equal to r cubed, take the cube root of both sides. So cube root of this side, cube root of that side. And so here I get the cube root of 3v over 4 pi. And on the other side, the cube root of r cubed is just r. All right, so I've taken the volume formula for a sphere, and I solved it in terms of the radius. So instead of me giving you the radius and you finding the volume, now I can give you the volume, and you can give me the radius. And you notice when we took the cube root of both sides, that cube root symbol went over the whole side, not just over part of it. All right, and that's the end of this section.